Let us start this new chapter called Parabola. We are already done with circles. So we'll be starting with this subtopic called conic section as a locus of a point. So what do you mean by this term conic section? So basically, if you have a cone and if you cut it through a plane, then this cross section, if you look at it from the top, then this particular zone, which is basically your cross section, this particular zone, will give rise to different shapes depending upon how your the plane is cutting. So it might just flatly cut like this to give rise to a circle. It might just get tilted and it might cut to give rise to this sort of a shape, right? It's a hollow cone, by the way. So this is not the important part. The boundary is the important part. So you might get a circle as a boundary, right? You might get a circle as a boundary. You might get an ellipse as a boundary. You might get a parabola as a boundary. So you might also get this shape called hyperbola. So these are basically the different conic sections that we are going to study in coordinate geometry. So we've already covered a particular conic section, which is basically circles. Now we'll be studying this next conic section called parabolas. After parabolas, we'll get to ellipse, and then from there we'll end the coordinate geometry section with hyperbolas. So what is conic section? Let us see conic section as a locus of a point. So here you will come across a very important definition. Any point P with coordinate xy such that its distance from a fixed point called focus divided by the distance from a fixed line called directrix is a constant ratio. Constant ratio. Very simple to understand. Let me just explain it in the layman's terms. So basically, you have this fixed point. You take this distance SP, right? This fixed point is called focus, by the way. You have this fixed line which is not moving, and you'll call this as directrix. You'll take the perpendicular distance of this point from the directrix, and if you take the ratio of this fixed point from the focus to the ratio of this to basically the distance from the fixed line, then this ratio has to be a constant number, right? It is a constant ratio, it is a constant number. This number is, by the way, called eccentricity. If your point P obeys this law, and by the way, if you rearrange, you will get this. If your point P obeys this law, then it is a conic section. Now, depending upon the value of E, it will either be a circle or an ellipse or parabola or a hyperbola. Let us look at what are the values.